Welcome to the exciting world of heat and temperature. From the sizzling summer sun to the cozy warmth of a fireplace, heat and temperature are all around us, shaping the way we experience the world. These words, hot, cold, warm, and so on, refer in some way to either heat or temperature, but what do these terms really mean? Temperature in simple terms is the degree of hotness or coldness of a mass. The temperature of a body will determine the direction heat around it will flow. Heat always flows from a region of higher temperature to a region of lower temperature, whether within the same mass or between masses. This heat flow will continue until there is no difference in temperature between the regions or bodies. Heat is a form of energy, and the heat energy of any mass or system is a measure of the total potential and kinetic energies of the molecules of the masses involved. The more the molecules in the mass are vibrating, moving, and rotating, the greater the sum of kinetic energy they have, which means greater total internal energy and in turn, greater heat energy. If heat is added to the system, the total internal energy of that system increases. But if heat leaves the system, then the energy level decreases. This could lead to a change in phase of materials by processes such as melting or freezing, or simply an increase or decrease in temperature. So what does temperature actually measure? What is this degree of hotness or coldness? Temperature measures the average kinetic energy of the molecules in a mass. It is now necessary to distinguish between the two terms, heat and temperature. First, heat is a form of energy, while temperature is a measure of this heat. Also, heat indicates the total internal energy of a body, while temperature is a measure of the average kinetic energy of a body. Heat energy depends on the size of the body, while temperature does not. So imagine a cup of water and a bucket of water. They might have the same temperature, but the amount of heat energy in the bucket is obviously more than that in the cup. This is because the amount of heat required to raise the temperature of water in the bucket will be more than that required for the cup. Finally, the difference in how they are represented and measured. Heat is represented by the letter Q, the SI unit is the joule, and is measured using a calorimeter. Temperature, on the other hand, is usually denoted by the capital letter T. The SI unit is the degrees Celsius or Kelvin and is measured using a thermometer. Generally, we can tell when an object is hot or cold from the sensation on our skin, but this is obviously unreliable. The range of temperature we can sense is limited and varies from person to person, so we use thermometers. Thermometric substances are substances that have a property that varies continuously with temperature, so we observe how these properties change with heat and use it to measure temperature. This is the way thermometers work. Mercury and alcohol are common examples of thermometric substances. They are found in most common lab thermometers that use volume expansion of mercury or alcohol to measure temperature. Other kinds of thermometers include the thermocouple, the bimetallic strip thermometer, the gas thermometer, the resistance thermometer, the pyrometer, and so on. Thermometers and how they work will be explained in further lessons. So, what is the difference between heat and temperature? Watch this again to remember. I'll see you soon.